Okay, so the other part of our lesson for factoring polynomial expressions is 3.1. So that ties to 3.1 in your workbook. So there's going to be some practice questions that you can try with that. So example 1 is looking at just factoring general quadratic expressions, similar to what you were doing in the previous part of this lesson. So remember that step 1 is looking for your greatest common factor. So in this case, I see 2, 2, and 12, so I can actually take that out of all of them. So I'm going to end up with x squared minus x minus 4. From there, I identify the type of polynomial. And specifically, am I dealing with complex? Am I dealing with simple? Or am I dealing with a difference of squares? Okay, because this is a simple trinomial, we're going to break it up, and again, we look for product and sum. So two numbers that multiply to give me -4 and add to give me -1. Well, the only factors for 4 are either 1 and 4 and 2 and 2. And in no scenario can this happen. So we would say that this part, our trinomial there, is prime. And so we're actually just dealing with the 2 and then x squared minus x minus 4. And then we were done. So we wouldn't say that the whole thing is prime because it's not. I was able to factor it a bit, but not any further than that. Now here I'm dealing with a decimal, which is not always our most optimal piece to be dealing with, but I can actually factor a decimal out. So if I want to take out a decimal, I'm just going to tell which decimal place I want to take. And then I'm left with, instead of 1, I would have to multiply 10 by 0.1 to equal 1. X squared, and then plus 14x minus 12. From here, okay, and if you're not sure about that one, just think about, okay, 0.1 times 10 gives me 1. 0.1 times 14 gives me 1.4, and so forth. Okay, from here, I'm going to check, and I have a greatest common factor here, actually, of 2. So I'm left with 5x squared plus 7x minus 6. So I factored, and I factored again. Now, if you could have spotted that you wanted to take 0.2 out from the beginning, good on you. I usually just try and get rid of my decimals, and then I deal with everything else. It's just a personal preference. Okay, these two pieces together, because they're just two numbers multiplying, can be put together, so 0.2. But otherwise, I'm dealing with 5x squared plus 7x minus 6, which is a complex. So I'm just going to work with it on the right-hand side here. And so using my crisscross method, I've got 5x times x, and I need to somehow get to 7. But I need to be subtracting here. So maybe if I have positive 2 and negative 3 to give me 6. So let's check it out. We've got negative 3x and 10x would give me my positive 7x. Oops, what's going on here? Okay, so it gives me my middle term. This does in fact give me 5x squared. This gives me negative 6, so that all works out. That means that this is one bracket, this is my other bracket. Okay, and that would be my final answer. Next one, fractions. Yay, fractions. We love fractions. maybe not so much. Okay, we would want to factor it out just like any other time. So 1/4, we need to multiply by 1 to get 1/4. So that stays like it is. What would we have to multiply by to get 1 if we're using 1/4 times what equals 1? How many 1/4 goes into 1? That would be 4. And how many quarters go into 3 wholes? Would be, if we think about it as 3 wholes, 1, 2, 3 wholes divided into 4 pieces, that's 12. Okay, from here it's a simple trinomial though, and I'm looking at two numbers that multiply to give me 12 and add -12, sorry, add to give me -4, so that's going to be -6 and +2. They need to be the same set of numbers for both, just as a reminder. So I've got 1/4 x minus 6, x plus 2, and I'm done. So yeah, just factor out that fraction. If you need to draw it out, this is 3 wholes, and it's also 12 quarters. Okay. So let's try this one, factoring out a half. We're left with x squared minus 2x minus 8. Again, simple polynomial from there. We end up with x minus 4, x plus 2.